All right, welcome to part 2 here, where we will be going over the database and API portions. So let me just walk you through the database architecture here. We're using MongoDB Atlas as previously mentioned for the solution. It provides reliability, scalability that a typical banking application would use. So there's two main collections. There's the user collection, which stores essential account information. Each user document has their own unique username and email that can't be duplicated. There's a backend check to make sure that that's happening. The securely encrypted passwords are using bcrypt, and there's real-time balance information for checking and savings accounts that are ensuring accurate financial tracking. The transaction collection handles all financial operations. Each transaction document records the type of operation, whether it's a deposit, withdrawal, transfer, along with the amount, timestamp, and references to the user's account. This gives us a complete audit trail of all banking activities, which is great. For security and data integrity, we also implemented several features. Passwords are encrypted before storage. Extensive data validation ensures accurate information, and we maintain referential integrity between collections. So not only supports our current features, but also allows for expansion of services in the future if we need to. Next, we go over the API architecture. So we had a RESTful API design when choosing this approach because it's simple, scalable, like I said, and widespread adoption has come to the banking industry for RESTful APIs as of late. And it's also built around two main categories, the authentication piece and banking operations. So for authentication, we have endpoints handling user sign up and login. They manage secure credential validations with JSON web tokens like we were talking about earlier, and it allows for secure access. For the banking operations, we implemented a comprehensive set of endpoints. So balance endpoint provides real-time account information, and then there's dedicated endpoints that handle deposits, withdrawals, and transfers. Each of those have validation to maintain data integrity and prevent unauthorized transactions. Security, obviously, it's a bank. Top priorities in API design, so every operation requires a valid JSON web token. We also implemented rate limiting to prevent abuse, which is really cool. And we also ensure proper error handling across all endpoints so that there's clear feedback for successful and failed operations. So there's a lot of console logs in the code that we'll go over and look into, and error printouts so that it's easier to look into debugging. Another notable feature is the transaction endpoint, which maintains a complete history of banking activities, which was crucial in going over, referencing and system auditing. So as we kind of go into a deep dive into the code with the deployment and additional features in the app demo and reflection, I'll show you what that looks like on a closer look.